Question 3 gives us our first synthesis problem on this exam. And in this case, we're trying to synthesize the molecule that's given from 1-propyne. So before we can do anything else, we'd be best served by drawing the structure of 1-propyne so that we know what we're trying to get back to. So 1-propyne, 3-carbon molecule, clearly doesn't include the aromatic ring. And so my initial thoughts would be that these 3 carbons here are the carbons of 1-propyne. And that makes sense because we know that we can put extra carbons onto the side of a terminal alkyne by removing the hydrogen and then adding an appropriate electrophile. But if we work backwards, we know that we can make an alcohol from an alkene. Specifically an alkene that looks like this. Again, we can continue backwards in our retrosynthetic analysis. An alkene could very easily come from an alkyne. And you'll notice if we make this from an alkyne, we're exactly set up for the alkylation that we talked about at the start of this problem. So it looks like we can do this synthesis in 3 steps. At this point, all we need to do are put the forward steps in, as well as their reagents. So in order to do this alkylation, we need to start by deprotonating the terminal alkyne. We need a strong base to do that. And then in a second step, we need to add an electrophile. So that gives us our extra carbons. Second step, we need to reduce our alkyne to an alkene. And we could do that either way. We could do that as a dissolving metal reduction with lithium and ammonia. We could also do this as a partial hydrogenation using Lindlar's catalyst. The only difference that would give us is whether we got the cis double bond or the trans double bond in the product. But our third and final step is a hydration, and that, at least in theory, works equally well on both cis and trans alkenes. Once we've made the alkene, we need to do a hydration. But notice here, we want the OH group on the less substituted carbon. So in other words, this is an anti-Markovnikov hydration, or addition of an alcohol. And we do our anti-Markovnikov addition of OH groups using hydroboration. And then second step, again, to quench the carbon-boron bonds using peroxide and base, gives us our final product.